Hi everyone. Today we're going to take a look at some limits, both graphically and by using a table. You can see that I have included a couple graphs that I made through Desmos, and they both, this function here, as well as our function here, both have x plus 2 in the denominator. They're both rational functions. And I think that everyone would know that if we used x equals 2, x equals negative. So by using x equals negative 2, we would get 0 in the denominator in each of these functions. With that, we all know that the functions would be undefined and there would be some kind of discontinuity happen. Now the question we're trying to figure out is what y value do each of these functions approach if we let x get closer and closer to 2. Sorry, x equals negative 2. Now if we take the x equals negative 2 and put it into the function up here, the rational function x squared plus 5x plus 6 divided by x plus 2, if you were to do that, you would actually get 0 divided by 0. And 0 divided by 0 has the term, it's called indeterminate form. And indeterminate form just means we can't figure out what the value is. It does not mean it's 0. It does not mean it's 1. We just cannot find out what that value is at all. Whereas if you put in negative 2 into the x plus 3 divided by x plus 2, we would get 1 over 0, which, as you know, is an undefined value. Now clearly these two graphs look much different. And why is that? That's what we're trying to find out. Why are these limits so different? So while we have indeterminate form on the top function and we have undefined value on the bottom function, the top function actually at negative 2, when x is negative 2, it seems like our function is getting closer to the y value of 1. Now I've taken the time to already fill in a table for you, okay? I've put in values on both of these, and I've put in values that are very close to negative 2. And if you look closely at those values, both from the left-hand side as well as from the right-hand side, or maybe I should say left of negative 2 and to the right of negative 2, all those values seem to be approaching, they're getting closer and closer to positive 1. And again, those are y values. And it confirms what we're seeing graphically. Again, there's no value at x equals negative 2 because I would have an undefined term, an indeterminate form, when I put that in. Now, looking back down at the other function, well, as I get from the left-hand side of negative 2 my values are getting closer, they're going farther and farther in a negative direction. They're going down here. But as I approach -2, from the right of -2, my values are getting bigger and bigger and bigger. Okay? So you probably remember the term vertical asymptote. So one side is going to the negative values, large negative values of y, and the other side, the right-hand side, are going to large positive values of y. That leads to, again, a vertical asymptote. Now, on the graph at the top, when I have this function, my values, my y values, approach, and the word approach is very important. They approach y equals +1. They never reach +1, but they approach +1 when x is -2. I'm going to change how I've written these terms, because on both cases I said y equals 1 and x equals -2, and I should have said y values approach 1. They don't equal 1. When x approaches -2. And how you write that mathematically is when x, for approaches, there's actually, you use an arrow. When x approaches -2, y approaches +1. So I've taken a moment to get another page and continue having the graphs there. So we have x approaching -2. When x approaches -2, y approaches +1. And there's more very specific notation on how to write that mathematically. And how you do that is you write lim, so limit, as x approaches -2, you put the x approaching -2 right under the word lim. And you must include the function that you're talking about. And we're talking about x squared plus 5x plus 6 divided by x plus 2. And that limit equals 1. Yes, the limit equals 1. The value of the function is not 1, but the limit as x approaches -2 of our function equals 1. Now, on the second one, we already talked about the values from the left are going to very large negative numbers, and the values coming from the right of -2, they're going to very high positive values, and we have this vertical asymptote. In that case, well, we don't have a limit because the values are going to different, as x approaches -2, the y values are going to two different directions. Okay, so the way we would write that is we'd have the limit as x approaches -2. I have to include the function that I'm talking about. So that's the x plus 3 divided by x plus 2. When that happens, the limit is undefined. I used undefined. The limit is undefined. You can use DNE, which stands for does not exist. If we had a different function, and both the left-hand side of -2 and the right-hand side of -2 went to positive infinity, if that happened, then I could actually say, and this is some different function that I'm dealing with, I don't know what it is, but our answer, we would say that it goes to positive infinity because they go to the same direction. We can't find what that number is, but we can tell folks that they're going in the same direction. Likewise, if I had another function, the limit as x approaches -2, it's a different function, so I'll call it g of x, it would equal negative infinity. All right, everybody, I am going to suggest that you pause this video and see whether you can find the values between A and E by looking at the graph. We don't know what this function's equation is. Clearly it will be a piecewise function, so there's more to it, and we don't have a table from which to look. We just have to look at this graphically. There is one concept that I want to add before you might go ahead and try to solve that, and that is the idea of left-hand versus right-hand limits. This means when you see this little negative sign up above the 1 here, that means we are supposed to evaluate our function as x approaches 1 from the left, okay? We are supposed to take, this means, again, as x approaches 1 from the left. All right, well, what's that look like? That means I am coming and here's 1, and I'm wondering what y values, as x gets closer and closer to 1, what y value is that taking on? Well, the y value it's taking on is 1, and so the limit of that y value is 1. The idea, again, for the right-hand limit, right, but as x approaches 1 from the right is how we read that, x approaching 1 from the right of our function, that limit equals -3, okay? So I'm going to be taking, and my x values that are just to the right of 1, really small values, where what y value is the function approaching. And it is approaching -3. The function value, f of 1, happens to be -3 as well. So the right-hand limit and the function value match, but the limit of the function coming from the left-hand side equals 1. And so we have some jump discontinuity happening, right in here. So take some time and pause this video for a while and see if you can come up with answers to those. So I hope you took the time to pause and come up with some answers on your own. I have included the answers that I believe they are. Check your answers, and I hope you did well.